Right now we look at the structure of queries and their processing. And as we've already indicated, we're going to do caching. So that queries tend to be related to each other. Further, queries vary wildly in their popularity. And some people like multiple, like I tend to often look at multiple result pages. But we can do prefetching, namely get the first page and get it up in front of me. So while I'm sitting there in a dazed fashion looking at that first page, the search engine can get all the other pages for me. And of course, caching and prefetching of results can but save computer time and shorten the response time. And all of these make the cloud happy, that's less computer time, and the user happy, that means a better response time. Here is a very old set of data, namely from 2001, when a very famous early search engine was called Alta Vista. That was a nicer name than the search engines we have today. Maybe actually only Bing sort of has a name. Google doesn't have a name except Google. So they had this particular search engine had in 1 month 7 million queries. They had 4.5 million distinct pages as a result, and the number of queries, distinct query strings of those 7 million queries, only 2.66 million were distinct. And of those distinct queries, 2/3 were requested only once. And the most popular, and the other, of course, were requested many times, because we somehow have to get from 2.66 to 7.16. That's due to just queries. So you can actually see from that the typical query occurs around a little less than 3 times. But that's a very complicated distribution. The most popular query occurred 31,000 times. And if we look at so those are the query statistics. On the result statistics, 48% of the result pages were only requested once, and 2% of all requested pages just correspond to 50 pages. So this is your usual long tail behavior. Namely, there's a lot of very popular things going on, popular pages and popular queries, and then there's a long tail of not so popular pages and not so popular queries. So caches all have an invalidation strategy. Exactly when you run out of space in your cache, you have to decide what to do. The simplest, the most obvious thing to do is you have a set of results in your caches, results to queries. You discard the least recently used result first. So you just make a list. Whenever you add something new, it replaces the last used one already in cache. So you can obviously do so-called prefetching, fetching results that haven't actually been used so far, but you believe will get used. And you have to worry a little in your cache about it being correct, because I pointed out the index changes. And you have to also worry about caching not just the basic response, but also the additional associated data, such as location, which you might want to keep in your query results. So we've already discussed Boolean query and vector space is pretty similar. If you have a query which asks for something which has the 3 words, dark, keep, and night, and then you just scan through separately for those. Those are the 3 components of a vector. You do that a little similarly how you would do the Boolean case. You just go through your posting list, then your index, you accumulate the star for each document. So here we have the 3 terms, dark, keep, and night. Here's the posting list, and then you can just add up the number of times these things actually hit, and you'll find document 1 has 4 hits. That's because keep occurred 3 times in document 1, and dark does not occur in document 1, it only occurs in document 6, but night occurs in document 1. So if you look at the scores, you'll find document 1 is 4 and document 2 doesn't have anything which matches. Remember, we're going to use TF-IDF and make more complicated components, and this will end up getting back to you somewhat more complicated probabilities and relevances in your final results. But the basic principles are always the same, and they're just straightforward use of indices. So if you like, what is the basic analytics here? Is indices with some specialized processing. Here we come back to something we've already discussed a few times, phrases. And there are 3 strategies to do phrases. Initially, if you just have the words, you find out the documents which have king, of, and Finland in them. And then you just have to rescan the document to see if king, of, and Finland occur together. A somewhat more efficient thing to do, which is probably what I suspect what most search engines do, is you store the word positions in your index because that doesn't take much space. And then you can actually check that of is in the word position after king and Finland is in the word position after of for a document that matches the index entries king, of, and Finland. The final thing you can do, of course, is to index king of Finland. If you really find a lot of people want king of Finland, then it's most efficient to index king of Finland as a special type of word. Notice in this whole model, we don't have to be unique. We can take the word king and make that king be an index and king of Finland be an index, and use the same information to populate those 2 vector components. There's nothing to stop you doing that.